I almost had an introduction earlier from Colin, and I was really intrigued. What did come up from Northern Ireland? Can I have a guess?
No.
Oh, really? That bad? Well, Northern Ireland is, I thought it might have been the Titanic, and we have an expression about the Titanic. It was all right when it left here. And that's the same that I have about production grades app. It was all right when it left me. So today I'm going to be talking about a passion project, and it's been really great seeing all the other applications today and different use cases. And this one, I don't think it could have been achieved without Shiny. It's going into secondary schools and demonstrating statistical concepts. And as we'll talk about later, it's a team of volunteers. And if we needed web developers to do this, it would have fell flat in its face. So Shiny enables these small scale projects and enables those projects to be achieved and used in that. So that's really important. So just a little bit of background about myself. Well, my name is Gareth Burns. I'm a data scientist at Exploristics. My previous role has been doing research in agri-food, doing forum sort of policy, so sort of government research, public bodies. And this is like epidemiology, marine fisheries, agricultural projects, flying drones, capturing multispectral images. And the data sets were getting larger and larger and larger, and they needed more programmatic skills. And R was just perfect for that, as someone from a sort of non-programming or software background. Then this led to my current role, which is in Exploristics. So I develop software. It's Keras Cloud is our software, and it's on, we use it in R, R6. Oh, is it loose? Sorry, I didn't see. Must be a loose connection. Oh, thank you. So it's deployed on Amazon Web Services. We use R6, object-oriented program within R, for clinical trial simulation, so cloud-based. And although this talk now is about a side project that I have, sort of the passion project, so it's not my main role. And it's more about scientific communication to the next generation in schools, and I'm really passionate about that. Hopefully that comes across today. So just a little bit of background information. I'm saying this isn't related to my role in Exploristics. It's related to PSI, which interestingly is statisticians in the pharmaceutical industry, so it should be SPI, and Shiny and Productions, SIP. So lots of acronyms with PSI today. And as the name suggests, it's an organization. It's about statisticians in the pharmaceutical industry. It does what it says in the tin. So it already had a schools outreach initiative, and this schools outreach initiative was going out to schools and promoting the sort of pharmaceutical and healthcare industry. So it was volunteers were going out, talking about their career, and also doing a demonstration, a sort of practical demonstration and trying to teach statistics. So it was about sharing and using those numerical and statistical skills in industry and highlighting what they have. But it was also about encouraging the next generation of students into STEM. So just to talk a little bit about the team that were doing this, we're a team of volunteers. None of them are here today, but they're all members in different organizations. So Steve set it up, as you could see. Alex was a teacher in a former life, so that's really good feedback to have someone within the team that does that. And just to highlight everyone there, and they're really good getting this diverse opinions to sort of develop that application, or this application that I'll show later. So in specific, what was our objectives? So I talked a little bit about, there already was a schools outreach program, but we're going into the classroom, doing things in pen and paper. We didn't think that sort of represented or highlighted the industry well. We thought it could be better, using Shiny apps out in the classroom. So what did we want to do with this? Well, we wanted interactive learning. We wanted students to be able to collect their own data and explore it so they could really engage with it. We also wanted it to be aligned with their level of data literacy. In some ways, we had a lot of talk about discussing what students would do, but it was aligned with the national curriculum, so we're able to see exactly what they were learning and what plots they were familiar with, for example. I'll talk a little bit about that later as well. We also wanted to do a bit of showcasing. We're going out in pen and paper, wanted to show off what we were doing, but not just for showing off. It was also important so they could see what tools that they would need and skill set they would need in the future. So that's showcasing element. We're all volunteers, so we wanted it to be fun and engaging. We're going out to a classroom with teenagers. If it's not fun and engaging, they're all going to stare blankly at you. If anyone has any teenagers in the room, they'll know exactly about that. So, just in terms of the timeline, how did we get this application to production? Well, this is how it all started. I don't expect you to read the text in this, but this is just a LinkedIn post from Steve, effectively doing a call for volunteers in the community. So it's getting out there who wants to volunteer in this sort of initiative. So some things to bring out here. It's volunteer-led. It's a community initiative. It comes with its positive. We're all really passionate, but we don't necessarily have resources. Our resources are limited. We're trying to beg, borrow, and steal. But no lack of passion. I'll just take it back, and this is the Squid Games. So Agile, I'll pick out Jumping Rivers then. Does anyone know? So Agile is a framework, if those aren't familiar, where sort of software development's often done, and everyone claims to be Agile. Does anyone know what Agile principle number 2 is? Didn't think so. Does anyone claim to be Agile in their team? So Agile principle number 2 is the one, welcome changing requirements. To me, this is the most ridiculous one because no one actually welcomes changing requirements. So I've changed this to a warning. And this project had no, just the same as any other project, there's going to be changing requirements. So I'm just going to talk a little about how to deal with them and what they were. And it's just a fact of life. You know, you're always going to get changing requirements, isn't it? So we started off, you see, the scope was literally as vague as that LinkedIn post. We want to do an application, a shiny application in schools as an outreach. So that's very vague scope. There was already previous examples or previous workshops that have been done, the pen and paper based approach. Like there was an Asthma workshop that says, well, actually, let's take one of the workshops we already have and use the Shiny app to have the data entry and sort of data visualization. So the scope's changing slightly. Then I developed this application, brought it back to the group, and the feedback was, let's do a different test. The different test was the Stroop test. I'll talk a little bit about this later. Don't need to know about it now. The point is, the sort of requirements or scope changed. Then developed this application, present it in front of the group. What happened? It changed again. It was a Stroop test with a crossover design. Again, don't expect everyone to know what a crossover design is, but just to get the idea that every time you're iterating over the feedback, people were coming back and having changes. And it's an important part of the process because it was making the app better, but when you're developing and you're constantly getting changed, it can at times be frustrating. So we settled on the Stroop test with crossover design. I was due to go to the classroom back to my old school. Really looking forward to it. Getting things ready. See my old biology teacher who was still teaching there. The sort of American movie, you're going back, you want to be really proud, show off your success. My application broke 2 hours before I was due to go back to school. As I said to Cara, I took a selfie of myself because it gave me something to talk about. But I was really panicking. The reason, that's shuddering again, sorry. The reason it broke, so the reason it broke was my application had state. 2 hours before I was about to go to school, and I'm panicking, my application isn't working. What do I do? I'll talk a little bit more about why. So let's just rewind. What did we want to achieve? Well, first of all, we wanted to bring this technology into schools. So were we bringing our solution to a problem, or was there a problem there that we wanted to solve? It sort of tends to be the case with Shiny apps. You develop something, you go, oh, let's create a Shiny app. When we looked at the curriculum, it said teachers should use their judgment about whether the ICT should be used in schools. The tone of that is actually I took it as quite negative, and we sort of had a bit of a crisis in confidence. Should we actually be using the Shiny app in schools at all? But I really thought we should. There was many benefits that it brought in to using not necessarily Shiny, but technology to learn statistics. It was we wanted it to reinforce the learning, so to supplement the learning that they had in the classroom. It was increasing the classroom engagement. They were collecting their own data and able to explore it. We really wanted to demonstrate the technological proficiency that they needed. This is important. They're going to come out into the world of work eventually, and this was aimed at GCSE students, I should have said. So they were going to come out, sort of demonstrate those skills that they need and use. And we also enabled real-time feedback, so we're getting visualizations and asking them a multi-choice question, and they could see that sort of feedback real-time, and they could see whether they demonstrated their understanding, and also the teacher could, or the person presented, could see that feedback, whether or not they were understanding the concepts. And there's also a generational shift. I think these are more digital natives, and they sort of expect this level of technology coming forward. So just to give a little bit of background information, I talked about we had like an Asthma workshops. This is a previous workshop. It follows a sort of, there's multiple workshops, but it follows the same flow. You go to the classroom, you're talking a little bit of introduction and giving information about your career. The students really like that career talk background, what you were doing on day-to-day level. They don't really have, obviously they're at school, they don't have much experience of the world of work, so they really wanted to learn, how do I apply these things that I'm learning in the classroom? We often done a randomization. So a randomization, for those not familiar, is the allocation into different groups. We work in clinical trials. You might have a treatment and a control group. This was often done using the toss of a coin. But that's a really good way of doing it because you have a visual that people can understand. Tossing a coin, half heads, half tails. You're demonstrating sort of randomization or randomness there. There was a practical experiment. And the practical experiment, in the case of the previous application was asthma, required equipment to be brought. These are volunteers throughout the UK. What happens if I want to give a talk in Glasgow, for example, or in London? You know, how does that equipment get about? It's the practical considerations. There was data recording on paper. You're having to collate that information and then trying to do this, and all within a 45-minute to an hour session, depending on the school and the sessions that have that. And then you were trying to do a statistical analysis and recap at the end. So there's a lot of stuff and a lot of moving parts there. And we really thought that a Shiny application could improve this process. And that's where we landed on the Stroop test. I'll talk a little bit about it in the next slides. Because we could carry out the randomization within the Shiny app. We could carry out the Stroop test, which you'll see in the next slide, allowed us to do the actual practical experiment without having equipment. So rather than posting that equipment about, we could do the test within the application. The data recording was happening within the application that allowed us to visualize the data and sort of do the statistical analysis within the application. So it's saving a lot of time, reducing your sort of resources that you need to post it about. So that's really useful and benefit to us as a group. So the Stroop test. The Stroop test, you might be familiar with it. It's named after Dr. Stroop from 1936. It's a psychological test that measures cognitive ability. And I'm going to try and do it now. This first one is easy. So it's you say the background color, so the color of the ink and not the word. Red, green, blue, purple, red, orange, blue, purple, green. It's quite easy. Why am I saying words? This test is then repeated where they change the background color. So remember, I have to say, I'm going to try this live, so it's being recorded, so hopefully don't make a mistake. Blue, orange, green, green, orange, red, green, red, red. So you can see it's slightly more different. It's a measure of cognitive ability, but for our purposes, it was just a test that we could do and measure both the before and the after, or the control and the Stroop effect. So it's really useful. However, I'm going to tackle the elephant in the room, accessibility. When I went back to the classroom, my biology teacher actually told me he uses this test to identify color blindness. So it's not a very good test for people who are colorblind. It's also, if English is your primary or secondary language, it's not a good test for you if you have other visual impairments. And this is probably the bit that I'm least proud about this application, is the accessibility. And we've had talks about Lighthouse for more general ones, but it's something that I would really want to improve on this application going forward. So I just really wanted to talk about that because STEM is for all, I think. Really, really passionate about that. So then in terms of the execution of developing the application, first I want to talk about abstraction. So abstraction, you often want to abstract away the logic and do something on behalf of your users. So if you think of Google, it's a really simple form. You've got a text input, a search. Say you're looking for a Chinese takeaway. You type in Chinese takeaway, hit search, and the first result is going to give you what you want. It's under the scene, or under the hood. That's much more complex. They've probably got your geolocation to know what Chinese takeaways are nearby. They've got your demographics, and it's probably the first one's going to be actually recommended by whoever's paid the most in terms of advertising. But you get the idea. There's a lot of abstraction away of complexity, and the application, you want to hide that from the user generally. But if you recall, our users are GCSE students who were trying to teach about these statistical concepts, so we didn't want to necessarily abstract away all that complexity. An example of this was our randomization process. So previously, this was done under the hood. As you went in, you got assigned to the different groups. Then there was they didn't, it was under the hood. They couldn't see what was going on. So to try and unabstract away, for lack of a better word, this complexity, we had a button where the users had to explicitly push it, and it brought out some information in terms of the randomization. I'll just show you. So we wanted a visual, which was that spinning round. So that's like a roulette wheel, given that previously it was the coin toss, which is a really good visual, but now it's easier to spin it around. We had a little bit of an info card to sort of give them information about what randomization is, and also stimulate discussion with a prompt and question. And the graph below was generated in ggplot, and it was their data, so they're able to explore it. So for example, if they got 5 of group B in a row, that's statistically unlikely, but it could occur, so they're able to generate that sort of statistical discussion. So this was done using Pedro's holy trinity of web development tools, which I had yesterday. Thank you, Pedro. And I really want to I've learned so much more from yesterday's class, so I can take this forward another level. You can add that interactivity and build the shiny apps a little bit, sort of to do these neat sort of things, which we're learning about in the responsiveness class, which was HTML, CSS, and JavaScript, and that enabled me to do that little roulette wheel, which I want to improve a little bit better. So that's really good using those tools. They make they make your apps sort of shine a little bit better and add a little bit of flair to them. The data, we had a persistent storage, so it was reactive polling and ggplot just to create that, just to give a little bit of background information about that. So in terms of the data entry, like I was talking about, when we were first going in, the application was more a data entry tool. They were going to do a practical experiment and enter it in. In the Asthma workshop, it had we had issues because we were having the user enter information about their gender, so we could do nice plots on that, segregated by gender and their personal details in terms of their name. That was giving us a bit of a data governance sort of nightmare. Did we want to collect this personal details about students? So we redesigned the app, and that's data by design. So that's a GDPR concept. So that's important to consider these sort of issues outside of it. We're not in isolation. We have to do that. Again, if I had the data entry thing, we're going to have a validation issue. These are GCSE students. They're going to deliberately try and break their app. They'll make the best software testers, but when you're in a classroom and they're doing stuff, you're going to pull your hair out. And also, if they entered the incorrect information by mistake, we'd have to have a mechanism to edit that data. I was the one doing this. I'm a volunteer. I don't want to be doing things that edit data. I want to be doing the fun stuff, creating the plots and visualizations. But editing data is an important thing if the data was wrong. So to overcome this problem, we thought, well, let's do self-serving data capture. And what do I mean by this? Previously, or initially, in an iteration of the application, they were just using their phone or stopwatch and someone was timing them. We didn't necessarily need to do this. We could let the application do it itself, and we had start and stop buttons. So instead of having the data entry, we were controlling it. The Stroop test would come up, or when the push start, the Stroop test would start, and then the push stop. And we're all so powering out the class. And that was a really nice way of doing it and demonstrating the results. Just the things that we'd like to highlight here. Well, it was achieved using R. Probably should have done it client side, but you can do some really neat stuff using R. That was invalidated later to create that sort of timer effect every 1,000 milliseconds. So it ticked up. But I think that the good thing here, or the really thing I want to bring out, is that custom CSS. When I first done it, it didn't have that stopwatch kind of feel. And I added that custom CSS to give it a nice feel and nice visuals. And they really make your app sort of pop and shine. And especially when you're bringing them into a classroom setting, you need that sort of more visual appeal. I had a lot of issues with state because there was, what was happening was I had multiple users. It works fine in the happy path, going through. As soon as someone else comes in, it was causing me a lot of trouble and spent a lot more time than I needed in the application here. So I encapsulated that using object-oriented programming, specifically R6, and that allowed me to reset all those values back better. So that was a problem when I was running the app. It would work fine the first time through, and then when you went back and tried to do it again, there was some of the values were being cached or retained, and the app was crashing because of that. So that's just something that occurred. Now visualizations. So we've had some really great talks. Today about visualizations, we've had many choices in the visualizations that we could have used. We discussed this. Steve is a member of the data visualizations group, and this is sort of passionate things that data scientists have when we came up with some crazy plots. One of the less crazy ones was every data scientist's favorite plot, the violin plot. But the GCSE students, this doesn't really mean much. It's not aligned with their curriculum. So it's important, I think, and just to sort of generalize that point, you need to know the data and technological proficiency of your users and align that with what they are. When we went to the curriculum, and Alex, who was previously a teacher, he could tell us they don't know what those plots are. I'm not dissing violin plots, I'm just saying align it with your user base. He said, at the GCSE level, they were familiar with box plots, so we put box plots in the application. Then just a little bit about the dynamic feedback. So in this, we were wanting to make sure that the users were So it's just in terms of a question. So to demonstrate understanding, it was that multi-choice, and it was based upon the data that they entered in. The question here is just, so the Stroop test is the plot on the top, the blue one, and the control is the box plot at the bottom. So it just takes a little bit longer to do the Stroop test, is what this plot is showing us. But then when they got the answer, if they got the right answer, we knew that they were able to see that information. There's also a bit of data exploration. They could see the plots, and we didn't do anything in terms of too interactive. We wanted to keep it as simple as possible. Providing them with real-time feedback, they were able to do it on their class data. Going forward, we're going to gamify it a little bit more. Give them more questions and give them a score. It's aligned with the example. And also with this, you can see the outliers, or maybe you can't there, but there's outliers in those box plots, and that stimulated discussion. The application went slightly wrong, because why is this an outlier? It's an outlier because the stop button didn't work. Is that a real outlier, or is it a fake outlier? What would you do to that outlier? So it generated discussion, and it was really good, and they were exploring that data and sort of bringing that out, which in a classroom setting, you really want those discussion points. So if we recall back, I was about to go into the classroom, and everything 2 hours before, things went wrong. What had happened was I had been developing, I'd always had a data set in the data. When I deleted the data set before going to the classroom, things started to fail. I had a nice validate within the plots, so I said if there wasn't enough data, don't create the plots. But when it was updating those 4 choices, there wasn't 4 choices that existed, and it was within an observe function, and the application crashed, and I'm about to go into the classroom. So that's what I would like. But this is a sort of, what occurred to me was I like to talk about this as the Pareto principle, and this is, you'll be familiar with it. It takes 20% of the effort to achieve 80% of the outcome. So this is great in terms of sort of minimal viable product and prototyping. You only need to do 20% of the work, and you've got 80% of the effort. This is great. However, this comes with a caveat, and this is really important in terms of managing the expectations of not only users or stakeholders, but yourself. You've actually only done 20% of the work. You've 80% left to do, but the perception is there's only 20% left to do, when the reality is you've 80% left to do. And the reasons why this occur, potentially, one of them is application state. You need to fix these things. You can't have an application that only works 20% of the time. It needs to work 100% of the time or fail gracefully. Other issues are just listed there. If it might be responsiveness, if you're using a mobile apps, it might be edge cases, scalability, security, documentation you might need to write. So that's important in the sort of getting apps to production. Shiny's really good at getting those quick prototypes, and especially, I was volunteering, doing this in my own time, maybe taking a little bit of shortcuts, not checking if it did have state. So just be wary that you're going to have to do that work at some stage if you want to get it into production. Now I'm going to do a brief walkthrough of the application. I was frantically panicking before this because it turns out that I embedded this as an iframe, and the IP is not static, it's a dynamic IP. So this wasn't working 10 minutes before I was coming into the talk. So this is the application run locally. Like I said, we brought it to the classroom. We want to really improve this landing page a little bit more in terms of making it friendly to the age group, but we're all volunteers, and we're not sort of graphic designers. What we're really wanting to bring forward, and we've discussed since then, about representation. So in STEM, it's underrepresented in terms of gender, so we're really wanting to bring out role models, and also so I wanted to talk a little bit about, like after this, about LGBT and how I can improve that. It's not an area that I'm particularly, aware of. So we're wanting to really have role models, and that would help with that. Just quickly going to walk you through the test. So the first thing, if you recall, was the randomization. So we've deliberately done it as a button. It's making the app more complex, but the reason it's making the app more complex is so that it unabstracts this logic, and you can see the data there where it's randomized it out. So they're just getting that feedback. We're wanting their initials. Again, we've done the initials rather than their names because we don't really need their name. We just want them to be able to identify who they are. We'd like to improve this a little bit, a bit of loading screen. I've already done the Stroop test, and I don't think I embarrassed myself, but potentially I did get them wrong. I'll watch the video and see. And this is that's actually the Stroop one looking at it. So then just the confirmation that they've got it right, just a simple value box to make it. A cancel button, that's also important. What happens if it went on too long and the user needs that? So the user might need different functions from your happy path from start to finish. I think that's also important when you're developing production apps, to account for what might go wrong, and users do all sorts of things. Then you have to repeat the experiment. I don't think it's self-explanatory, this. That's another thing I would like to improve in terms of the design. But like I say, we're all volunteers, and we've got this to the classroom setting. Now we need to take it to the next one, our next phase. So that's just the test. We can see the results are put there, result 1 and result 2, so it's randomized the process. So then we just submit the data. Again, just a little prompt and a loading screen. Without the loading screen, people weren't know what they're doing, and people were bashing the button. So that loading screen prevents people from bashing that button, and that's where things can go wrong. Then we sort of gamified it a little bit better. This is where I demonstrated the app earlier, SIP, Shiny in Production. So that's not real data, that's just me randomly clicking stuff. So we were just trying to display that. They could explore the data, see what their result was, compare it with their classrooms. They want to be, as soon as you have a leaderboard, people were just hitting start and stop really quickly. So you need to make sure you account for that. But I don't think there was anything wrong with that. If it was fun and engaging and you're doing it in a nice way, we weren't really trying to collect results. That wasn't the real purpose of it. It was just a tool to talk about statistical concepts. And then here's just the visualizations of the data. We might, at the minute, just a histogram and box plot, because that's aligned with what they're doing. The question here, just in terms of the multi-choice one, so we could see if they answer it. They're getting, like it's talking about real-time feedback. So that's useful. Let me try and see. I think I can hit P. This is an iframe embedded within it. How did I get to the next slide? That's the problem with trying stuff. Sorry. So just in terms of the feedback, this plot, if you're not familiar, is the Likert scale. It's that classic question, do you agree, strongly agree, disagree? We had paper questionnaires. So the reason why this is mostly empty on this side, if people were strongly disagreeing, the bar plots will go over here. So that's quite a good indication here. I'm not going to go into the details. So most of this was strongly agreeing in terms of the 10 questions. The questions were related with what we wanted to do. I just don't want to talk about each of the individual questions, but the question 1 was actually about the sort of, I talked about my career, and that was what engaged them the most and had the most positive. So it wasn't the application per se, it was getting out there and just talking about your experience as an individual. So that was really nice to get that feedback. Teenagers like to hear what I had to say, and that's probably the first and only time I will say that. So just to finish up, how can you all contribute in the room? Well, provide feedback. I've already got, what went on the responsiveness training course, took a lot away. I'm going to do that. If anyone else has any feedback, alternative tests that are more accessible, how I can, if the LGBT community, is there anything I can do, to bring those things in? I would love to hear that and bring it in. Promoting STEM yourself to the next generation, get out there. This isn't just necessarily limited to this. We're all volunteers who do it out of passion, not for a career. You could potentially join the team if you wanted to write code in your own time with this. And just to finish up, you could also ask me questions and challenge me to do things differently. So that's an invite for you all to ask me questions. Thank you.